cos of xt times, parentheses, what's the derivative of x in terms of t? X prime, or dx dt, yes. Plus, what's the derivative of t in terms of t? Yes. Derivative of t in terms of t? Yes. Now we're solving for dx dt. There it is right there. You see it? So in this case, you could just divide both sides by that cos xt to begin if you wanted to. So because you're not going to have a denominator on the x prime. Subtract x. And now I'm going to divide everything by t. Divide by t, divide by t. Divide by t is the same as multiplying by the reciprocal. So that's the same as times 1 over t. Work through it. Check out the algebra. We're working out a couple skills now. You're working out implicit as well as some nasty algebra. This is the ugly stuff. So just practice it. Amina.
Why can't you, in the last step, why can't you have close x to the squared?
What was, when was it?
Like,
Oh, I see what you're saying. This graph, is this the same as cos of 4x? You can't bring that on the inside. You know what I'm saying? This affects something, this is something different. You know what I'm saying?
Yeah.
So these are separate. You can't go inside those parentheses. Does that make sense, you guys? It's a great question. Yeah.
Is that the same as saying when you divide by x minus x over t?
Secant x, yeah, this is the same as secant xt minus x over t. Bam. Can you guys recognize that? That was a solution? Yep. Well, you can look at that as 1 over t times 1 over cos xt. Flip this up, this becomes secant xt times 1 over t, or just over t. But 1 over t is the same, you know what I'm saying, since it's multiplied?
Right. No, yeah.
Oh, yeah. Well, he said, I'm sorry, you said it like this, right? I think what he was saying was this, because then he combined his same denominator, you can combine your numerator. So that's what you meant, right? I see what you thought it was just, yeah, I see what you see. Yeah. Okay. Yeah, he combined in that same denominator, secant xt minus x over the t. Call. Yes?
Would it be possible to like draw a picture of what t is for finding? Because like I'm just having trouble like.
Oh dear. So some of these functions, like, I mean, look at these things. You know what I'm saying? Like, you can't graph this on your calculator. Because you can't, like, get this in y, you can't solve for y. You know what I'm saying? You can do some in parametric mode, which we'll work on, like, when you convert between one and the other. But so here's the deal. Like, in a lot of these functions, they're going to give you the nastiest thing ever, and their goal isn't for you to be like, let me picture the function. This is what the tangent line would look like there, so now let me solve for the instantaneous rate of change. You know what I'm saying? What this is some nasty function. And like these are. You know what I'm saying? This is kind of as nasty as it gets. And they just want you to use implicit differentiation to find the instantaneous rate of change of this thing at a specific point. You know what I'm saying? Like the goal of these is not to see it kind of happening. You know what I'm saying? It's just to practice. If you can do these, then you can take the derivative of some other one, like a circle or an ellipse, and then you could make that and then like draw on your tangent lines. You know what I'm saying? But you'll never be like, by hand, no calculator. Graph this and then tell me what the tangent line looks like. Do you know what I'm saying? It's just it's just a big nasty mess. It's purposely. Does that help? I know it doesn't answer your questions, but I wouldn't focus on for these, like what it looks like. Okay, this is the sign, because your y is buried inside. You know what I'm saying? If t is y, so your output is like part of the input. You know what I'm saying? Like, what is that? Well, that's not our goal right now. Do you know what I'm saying? Like, if this was a y, what does this graph look like? Sine xy equals y? Where the output is part of the input? I don't know. You know what I'm saying? Or it could be two different things. But the goal of this is to understand implicit differentiation. You know what I'm saying? Getting this done. You know what I'm saying? The ones you'll actually do, the applications, the equations will be cleaner, and the equations will make sense. And that's chapter 4, when we start using this stuff. Does that make sense, you guys? Now we're learning the skills. This is the toolbox. We're learning all the skills to do the applications in chapter 4. Okay? Question? All right, try 14. So it'd be, the t would go in this denominator. All right, there's your derivative in 14.
Wait, is there an answer sheet that goes along with this?
I have one.
Can I see it? Like just for up to 15?
The answers have been on the board.
Multiplied by half.
So let's work on this one.
How do you get that one?
I know, but we also have to multiply this by half because of this power rule.
We have even 16 now.
I can't see, I'm tired.
The answer to this one is -3/5. -3r over 5x. Why? What do we do? All three of these things are multiplied together. What do you do with the exponents? You subtract the exponents. All right, homework's on the board. 8 problems.